In scientific measurement, we sometimes have to use something called derived unit or complex unit. This is something that just isn't meter or just isn't gram, but involves other dimensions or other types of measurements as well. For example, if you've ever watched a medical show, you have a doctor going and say, "Nurse, I need 6 cc's of Thorazine, stat," right? I know they keep saying stat, and maybe they don't really like statistics, but they keep saying stat, right? And the important thing is that they've used 6 cc's of something. And 1 cc is equal to 1 milliliter, okay? 1 milliliter, 1 cc. cc stands for cubic centimeters. Okay? A cubic centimeter is a milliliter. So a cc is a milliliter. I don't know why they say, "Nurse, I need 6 milliliters of Thorazine stat." Or now. "Nurse, I need 6 milliliters of Thorazine in a couple of minutes." You know? But, you know, everything on television is some sort of emergency. So that's what a cubic centimeter is. It's a milliliter. Okay? If you think about a cubic centimeter, though, I'm going to have a centimeter. All right? And since it's cubic, I've now done one thing to it. So 1 centimeter here, if I square it, it means I've got 1 centimeter on either side. And a cube is a square that also has the same distance on the back here. So this length is also going to be a centimeter. So height, length, and depth, all of those are 1 centimeter. It's a cubic centimeter. And a lot of people look at this and they say, "Okay, gotcha, easy enough." So then I throw this at them and I say, how many cc's in a cubic liter? Or in a cubic meter? And they're all like, "Oh, cubic meter, cc's, it's a milliliter, you go up to a liter," right? Not really. Okay? And this is where derived units comes into town. Okay? So, if I take this cubic centimeter, and I'm going to look at this and say that I've got 100 centimeters for every 1 meter. If I want to look at that meter and I say, okay, where am I going from there? I need to cube the value in order for this to occur. So for meter, it's not so bad. I take meter and I cube it. Okay? That means I take the cube and I have to apply it to everything that's on the inside here. So what this now becomes is 1 cubed and meter cubed. Meter cubed being the unit which describes what mathematical function I've got and what this unit is applied to. It's a volume measurement because that's a cubic measurement. Okay? So 1 cubed, what's 1 times, so the cube, if you remember your math, 1 times 1 times 1 is a cubed value, so what's 1 times 1 times 1? 1, all right? So there you go, 1 meter. It's an easy calculation. So I'll write this down here, 1 meter cubed. However, if I do something to one side of the equation, I always have to do it to the other side of the equation as well. Oh, yeah, what's going on? Oh no, what's he done? Yes, you've got to cube the 100 centimeters as well in order to get the representative value for this derived unit. Okay? So that means I have to apply the cube here. So not so bad with centimeters cubed. There you go, centimeters cubed. CC, haha, nurse! But with the 100, things get a little bit more complicated. Once I cube that, that's 100 times 100 times 100, okay, or 100 cubed. Notice at this point, I don't have 1,000 milliliters, which would just be defined as a liter. Now I've got 6 zeros. 1,000, or excuse me, 1 million cubic centimeters is equal to 1 meter. All right? How many liters is that? It's 1,000 centimeters, or 1,000 centimeters cubed. We know that this is also a milliliter. So I've got 1 million milliliters. And how many liters is that? That's 1,000 liters. Don't make this mistake of trying to keep things linear when they become derived units. Okay? Another type of derived unit that we use is going to be things that have two different types of measurements that are associated with them. And to do so, I'm going to magically clear the board now. Was that magic or was it science? It may have been a pause button on the recorder. So now I have derived units, right? Okay. Complex units. These are things that have more than one measured value. Right. You guys are well aware of a couple of complex units. And I'll give you an example. Miles per hour. It's a complex unit. You see this and you always think miles per hour, MPH, blah, 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 blah. What does it mean? Well, miles per hour, obviously, if I'm driving 60 miles for every 1 hour, right? What this is a measurement of distance with respect to time. A derived unit, or now at this point it's a complex unit, because now I have applied time to my distance, which implies that I have an object which is moving at a certain velocity. Okay? So, miles per hour. If you're taking physics, then you will have run into acceleration before. Okay? Meter per second squared. This is an acceleration term. Alright? Once you apply energy to an object, that will either accelerate or decelerate the object. That is a function of a meter squared. Your distance versus the square of time. Okay? In chemistry, we're not worried about acceleration and deceleration too much, but we do have some complex units, such as density, that you'll need to be aware of. Density, what this is mass over volume. Alright? And in this case, generally it's grams per milliliter. However, this is for liquids. Okay? When you get to gases, you can be talking about grams per liter. That's another measurement of density. Anytime you have mass versus volume, it's density. Okay? So grams per milliliter. You can have milligram per milliliter. You can have microgram per milliliter. Okay? Again, all of these are density measurements. You can also be measurements of concentration as well. Concentration, which is similar to density, uses something called molarity. And molarity is equal to moles for every liter. It's similar to density, but moles is not used for mass. Moles is used for counting. So this is for units per liter. Okay? For molarity. So concentration is how many units do I have in there? Do I have one chair inside of a room? It's not very concentrated. Do I have 300 chairs inside of a room? Now, suddenly, it's become a lot more concentrated as far as chairs go. Right? Okay, so it's a concentration term. Again, another complex unit that we're going to run into. Whenever we have these, we have to be aware of how they are presented. Okay? So I'm going to go back to density. If I have something that has a density of 1.54 grams for every milliliter, okay, I can represent this using box diagrams. 1.54 grams, okay, so I'm going to put this into a cross diagram, for every 1 milliliter. Okay, and make sure that these things are placed in the correct form. You may have to divide or multiply based upon what's going on. We'll talk about some examples of that later. Talk about significant figures.